Okay, so this is part 2 of the January 2016 International S1 paper for Edexcel. It would be useful for both the home version of S1 and the international version of S1 for Edexcel. Because similar questions, to be honest. So we've got, this is all about, there's some coding going on, and this is regression. Okay, and we have all these formulae for regression, which is given in the formula book. Look at page number, page 17. Okay, so the first question is to find SVV and SSV and SSS. So SVS, I said the wrong symbols, but it doesn't matter, is equal to, right, let's have a look at the formulae. It's this second version of the formula that we normally use. Okay, the first one involves some difficulty with rounding because you have to work out the mean normally. So it's the second version that we use. For the first one, it's actually the one where the symbol is different, X and Y. So it's the sum of them, the product of them, times by the sum each of them individual, the product of those two, divided by n. But let's just write that formula out, but with the different symbols in. So that's sigma Vs, take away sigma V, sigma S, divided by n. Now in this case, we've got all the summary data here. We don't need to work it out again. We've got sigma Vs is there. So that's SVS is equal to 177.311. Take away sigma V, which is there. I mean, obviously it's the same as the sum of these numbers, but you're saving your time to use the summary data. So that's 29 times sigma S, which is also given to us, which is 36.8. Divided by the number of numbers, which is 8. Now that equals to 43.911, which is 43.9 to 3 significant figures, which is fine for accuracy. So B, no, it's not B yet. We've still got to work out SS. We'll refer back to our formulae here. When you talk about the individual symbols, then it's the, if you look at it, it's the sum of the squares, take away the sum squared divided by the number of numbers. So SSS is equal to the sum of the squares of s's, take away the square of the s's squared. You can see those are different. This one, you're squaring the numbers and then summing them, whereas this one is summing them and then squaring it, which is quite different. And then that's divided by n. So that equals sigma s squared is given to us, 209.72. Okay. Then take away sigma s is also given to us, 36.8 squared divided by 8. And that equals to 40.44, but if we round it to 3 significant figures, 40.4. Okay, so that's question A now done. Right, now for part B, product moment correlation coefficient. We've got a formula for it here. It's the sum SXY divided by SXXSYY. So that's equal to, obviously, that in this context, R, well, with the difference with the changed symbols, is SVS divided by the square root of SSS SVV. Now, to avoid repetition, examiners will often give numbers. They don't want you to repeat the same process lots and lots of times. They want to test you on lots of different things, and repeating the same exercise over and over again is not a good way of testing what you can do. So that's why they've given that number there. That's on the bottom. We've worked out the number on the top, but I'm going to use obviously the unrounded number. So store that in your calculator or whatever. Divided by SSS. Again, I'm going to use the unrounded number, which is 40.44, times by SVV, which is given as 55.275. That equals to 0.2875 and a lot of other stuff. Let's round to 3 significant figures, so 0.929. Okay, C. State, given a reason, whether or not your answer to part B supports the publisher's belief. And the publisher's belief is that a linear regression model might be appropriate. We don't use a linear. It's not appropriate to do a linear regression model if it's very spread out the data. But if the correlation is strong, then linear regression is appropriate. So the answer is the correlation is strong. So yes. So yes, my answers you must say that yes. Don't you've got to complete it because they're asking you to say, do your results support the claim? So you've got to say yes or no. Yeah, so yes, my answers support. So you can say it. You might choose to say that first rather than do it that way around. I've done it, but that wouldn't matter. But you must say yes. So yes, my answer supports publisher's claim. You might also say R close to 1 to kind of really ram the point home, which is not, I think, in the mark scheme accepted either or, saying correlation is strong or R close to 1, but it does no harm to say both of those things. Okay, so that's part C, just 1 mark for that. D, find the equation of the linear regression line on S on this. Now we're going to refer back to our formulae now, and we work out B first. Right, here B is Sxy over Sxx, right? But our kind of equivalent of the x here is V. So in this case, we've got B is equal to SVS over SVV, which is equal to 43.911 over 45.275. Now, I probably shouldn't say this, but I would always suspect that you're going to be used any given answers for something like that rather than one that you've worked out, just for ease of marking. I'm not surprised that they've made it that way around, so the one you've given is the one that you need for part D. If they'd asked you to work out SVV and given SSS instead, then there was always a problem with follow-through issues with part D. So I'm not surprised they did it that way around. Anyway, that equals to 0.7944. Store it on your calculator, but I'm going to round it to 0.794. Right, now there is a formula to work out the A as well, which you might choose to use. I'm not in the habit of using it, so I'm not going to here because it's pretty obvious how it works. We have S bar is equal to A plus B V bar, because our regression line has to go through the mean point. That's 1 point on our line. Okay, so if we want to work out, if we want to work out A, we just do S bar take away B V bar. Okay, it's given in the formula book effectively there, but I always tend to just write it out and then just take the thing the other side. Saves me looking in the formula book again. Anyway, and I also know that I've gotten the symbols the right way around that way as well. Haven't had to deal with that rather than getting V and S the wrong way around or whatever. Right, so we're going to need to work out S bar and V bar. Well, it's not difficult because we've got the sum of S and the sum of V. So let's work out S bar is equal to sum of, well, I don't need to write all the symbols, surely. That's sum of S, which is 29, sum of S, which is 36.8, over the number of numbers that there are, which is 8. Okay, and V bar is equal to the sum of V, 29, over 8. So A equals 36.8 over 8 minus B, which we've worked out from before. I'm going to use the full calculator, stored number in my calculator to work that out, to avoid any rounding issues. I'm not going to refer back to my three significant figures one here. And times by V bar, which is 29 over 8. So that gives me A equals to A, when we work that out, equals to 0. Oh no, it equals to 1.720. Let's go for three significant figures, 1.72. Okay, let's write our final regression line in. That gives us S equals to 1.72 plus B, which is 0.794 times by V. Okay, so part D is referring back to, because I remember our original data was about books, sales of books, and the data that we were given V and S was coded. So they want us to just go back to the formula with Y and X. So all we do, there's our coding formula there, and we put those numbers in for V and S. So we have Y over 1,000 because of that equals to 1.72 plus 0.794 x plus 50 over 200. Okay, so and then we just have to rearrange that. I'll just quickly do that. If I times everything by 1,000, rather than do everything on a calculator here, I'm going to, because it's a bit fiddly, times by 1,000, that will be 1,720. Okay, now that will be plus 0.794 times 5 times x plus 50. You want to do y by times 5? Well, I decided I'd rather get rid of the fraction rather than do the 794. So that's because 5, because I'm doing 1,000 divided by 200. But it's not the only way, but I'm just trying to avoid doing too much with my calculator. I will now refer to do the calculations on the calculator. So the next line is y equals 1720 plus 0.794 times 5 times x. So that's 0.794 times 5 That's 3.97 x plus 0.794 times 5 times 50, 198.5, but I'm adding that to the 1720. So I'm getting 1920 to three significant figures. I'm getting 1920. So I'm getting y. Oh, I forgot to write the number here, which is equal to, let's say this is when we combine these two together, when we go to three significant figures, that's 1920. We're practically adding 200, and that's 3.97 x. Okay, so that's part D. So we're nearly done with this question. Right, oh no, that's part E. I've done two parts of these, never mind. Then, the publisher calculated the regression line for a sample of novels and obtained the equation 3100 plus 1.2x. She wants to increase the sales of books by spending more money on advertising. Well, let's have a look back at what the whole thing's about. A publisher collects information about amount spent on advertising and sales for some of her publications. She collects information. Right, so a publisher collects it about the amount spent on advertising and the number of books sold. Right, now here it says he wants to, the publisher calculated a regression finding for a sample of novels and obtained this equation. She wants to increase the sales by spending more money on advertising. State, given a reason, whether the publisher should spend more money on advertising textbooks or novels, because the original work we did was on textbooks. And the answer is that it should be textbooks, because the gradient is more. If every extra amount that is spent on advertising textbooks produces more money, because so for every, whatever the units are, well, that doesn't actually say, yeah, it's for every pound spent on advertising, it sells 3 or nearly 4 more books for this one, but only 1.2 more books for the novels. So the answer is textbooks spend more on textbooks because the gradient is greater. We might also say that's enough for the schemas. In this case they were took, but I might say the extra, for every extra pound sold on books, on advertising, for every extra pound paid on advertising advertising textbooks, nearly 4 extra books are sold. I'm probably saying, I am definitely saying much more here. It is about the gradient, but other questions sometimes want you to put things in context, so that's what I'm doing here. So this is a little bit more than was required for this particular answer, but sometimes it's difficult to know. I suppose it's 2 marks. So for every extra pound paid on advertising textbooks, nearly 4 extra books are sold, whereas the equivalent figure figure for novels is £1.20. Something like that. That's more than is required, but at least we put things in context there. So for those economists amongst us, it's all about marginal rates. Margin, we get more, we sell more, that much more extra for every extra amount spent on advertising, so it increases by more. Okay, that's question 3 done in 20 minutes. Probably waffling on a bit much here. Let's see what the next question's about. All right, I've obviously prepared it. I will just rub that out and start that. Okay, so it's a tree diagram question. It's about a training agency awarding certificates for completing a course, and they can take it 4 times, but the probability of them passing each time reduces by 0.2. So we can see that this line, the first question is to complete this tree. Well, first one, I suppose, we can fill that in because it's the probability of passing is reduced by 0.2 each time up to the 4th time. Of course, can't reduce any more than that, not by 0.2 anyway. So that's the 4 branches. And we know that obviously any 2 branches have to add up to 1. So this is 0.3. This here is 0.5. This here is 0.7, and this here is 0.9. Okay, now that's nice, easy 2 marks. And then it says find a probability that the student was awarded the certificate. Well, we've got this bit here, which is, we've got that bit there, which is 0.7. Okay. Then this branch here, which is, that means failing first and then passing, so that's 0.3 times 0.5. Okay, let's write to the title, probability passes equals that. And then for this branch, fail, fail, and then pass, that number comes to 0.3 times 0.5 times 0.7. And then finally the final branch here, starting on a new line, plus 0.3 times 0.5 times 0.7 times 0.1. And that comes to 0.9055. Nothing too difficult about that really. Nice tree diagram question so far. Right, now part C, conditional probability, is the name of the game here. Given that the student is awarded a certificate, find the probability that the student passed on the first or second attempt. So probability that they pass first or second, conditional on passes at all. In other words, does not fail in the first 4 attempts. That's equal to the probability of both of these. Now that might seem a bit strange. I'll talk about that in a sec. Always the probability of both of them happening divided by the probability that the conditional statements happen. So passes. Okay, well, this is a bit strange because of course if they pass first or second time, they've also passed. It's an example of an event, if we did a Venn diagram for it, being entirely enclosed in another event. Here, this would be passes first or second time, for example. and this would be passes. So it's one, if they pass first or second time, if you're in here, you're also in here. So that's just the same as passes first or second time. So passes first time, that's 0.7. Passes second time, because it could be either or though, so we're adding them because those two are definitely mutually exclusive. So that's plus 0.3 times 0.5, all divided by the probability of passing, which is a number that we had before. So that's 0.9055. That comes to 0.939 or 0.9387. Given four significant figures now. Okay, so that's part C, not too bad. Conditional probability. Let's say divide, you're always dividing by whatever this thing is. It's basically the rearranged multiplication rule. Okay, let's do part D. Okay, so this is an adjustment. So this tree diagram is no longer there. It's not this one. This time there's only 2 attempts. The agency requires a probability of passing the test at first attempt to be P and the second attempt to be 0.2 less. Okay, well, okay, so let's just start out. So there's going to be fewer branches on our tree diagram. Obviously we're going to have P and 1 minus P. Probability passes, probability fails. Now, if they pass, then obviously that's the end of it. But if they fail, then they get another go. But the probability now of passing is going to be P minus 0.2, because it says that. Now, that, then because these two numbers have to add up to 1 take away P minus 0.2, is going to be equal to, and you work that out, 1.2 take away P. As a check that those two add up to 1, and they do. The P cancels and 1.2 minus 0.2. Okay, so that's our tree diagram. I didn't ask for a tree diagram, but it's kind of going to be a good idea to get this out of it. So it does say that the probability is the percentage of students who complete the course needs to be 95%. So we need, obviously, that it can happen by 2 ways. It can pass first time, or they can pass second time, which involves failing first time and then passing. So I didn't actually need to put that effort into working that out, but never mind. I'm kind of interested anyway. So that needs to be equal to 0.95. Okay, so if I multiply that out, hopefully I'll get this, what might have been initially a little bit frightening, we'll get this equation. So that's P plus P minus 0.2 minus P squared minus 0.2P equals 0.95. And if I rearrange that, I get P squared, well, it should be plus, obviously, 2 minuses multiplying to a plus. P squared minus 2.2P plus 1.15 equals to 0 as required. Okay, so then it's about all about solving the quadratic. So we're going to C1 but with a calculator, because obviously we're not dealing with surds here. So I'll just write it below here. So for E, we've got P is equal to, now the value of B is 2.2. Now you might be tempted to put plus or minus, but I'm going to leave that blank for a moment. Plus or minus the square root of 2.2 squared minus 4 times 1 times 1.15, all divided by 2. I know it's going to be the minus sign, because if I add, you can check it if you want, I suppose it might do, that one's going to give a probability of more than 1, and so therefore that is not appropriate. The reason why I know it's going to give an answer of more than 1, by the way, is 2.2 divided by 2 is equal to 1.1 already. So if I'm adding to that total, then I'm already I'm even bigger. So 1.1 is already too big. So I know it's got to be taken away. So that answer is 0.855. Okay, and that is it. It's quite a long time for 2 questions. 30 minutes up. We'll have to do the next 2 questions in part 3.